Okay, hello everyone. Recently, I've decided to learn PyTorch, one of the well-known machine learning frameworks or deep learning frameworks to be precise. In order to give a background, in college, I had a assignment that I have to do for the machine learning course that I've been taking, and I decided to use PyTorch in order to learn about how it's used, but I couldn't really use it efficiently and didn't really get the results that I wanted. So in order to change that, I've decided to learn PyTorch starting from the ground up and really understanding its fundamentals and its building blocks that are important to its nature. So I am going to post videos about the things that I've been reading and learning and trying out about PyTorch. And, maybe together we can learn more about just deep learning and also learn how to use one of the most popular deep learning frameworks, PyTorch. So what is this library? I've been talking about it for beginning from the video, but it's one of the most well-known frameworks of deep learning, and it's mostly preferred by researchers and also professionals to develop production-ready machine learning workflows and also models. There's my cat meowing, looking for attention, but it's not the right time. It's not the right moment. So it uses tensor data type for its building blocks. I'm going to talk about those later part of the video. Let's just import the library here in Python. I will be importing it using Torch. You're going to do that too. You can also follow along if you want. So the first thing we need to talk about is the back side, the back end of PyTorch. In machine learning, you will be working with neural networks with huge sizes. What is it? My cat is meowing. What happened? Excuse me. So in PyTorch or in machine learning and deep learning, you can use two devices to execute your computation and also store as a storage. If you don't know, usually in these areas people will prefer usage of GPUs over CPUs for several reasons. If we want to work efficiently with with PyTorch, we need to define an instance of a device in our workplace. So device is just, let's just type in the markdown. So device is just an instance of a hardware instance of a component, and this is used for storage and also for computations. We will expand on this, but what we need to do first is to define a device in our workflow. We can do that with using if-else statement, and there is a method that is provided by PyTorch called isAvailable. That's it. So in the description, we can see that it returns a Boolean value that indicates if CUDA is currently available. So CUDA is important. It's a key term here. This is an architecture type. It's an approach to the architecture that is used in GPUs. This enables parallel computation, and because of this, we can accelerate our computations when the device is defined as a GPU. So this checks whether we have a CUDA device, which means that if a device we have has a CUDA architecture, that is usually a GPU or a TPU. So we can check if this is available. If this is true, then we can print that the CUDA is found. What happened? I'm I'm busy right now, and I can bound my device into this GPU that I detected. I can do that with using Torch class called device and create an instance of the device, and I will be naming it CUDA and the indexed 0. This is usually the dedicated GPU you have in your system. If I couldn't locate any CUDA based device, which means if like maybe I don't have a GPU or any TPU or any device that has a CUDA architecture, I can print out a message that is letting me know that I cannot find a CUDA device, and I will be bounding the device to the CPU, the only available device other than the GPU I have. Okay, and we will do the same thing, but right now at this time we will specify it using CPU. Okay, so when I run this code, as you can see, it printed out this message. So the CUDA is found in my system and the device is bounded. I can check this with running the device parameter, device variable or instance, and I can see its type of a CUDA device and the index is 0. And as I said before, this usually means the first dedicated GPU you have. This is important for some cases if you have like more than one GPU available, or maybe you have like a cloud, if you're working on a cloud. Then we set our device successfully. Now we have a device to work with and center our computations around. Another thing we need to talk about, and I previously mentioned this, are tensors. So what are tensors? Let's just add in like heading. So tensors in simply, or let's just talk about arrays first, okay? So arrays are a sequence of elements. What do I mean by this? What I mean is when like let's say that you have number of elements, like few elements that are like floating points in this format. What is it? Do you want to go out? I apologize for the intrusion. My cat is just demanding. I don't know why. So let's just say that I have sequence of numbers. Now in mathematics you can call this vector or an array, right? But array usually means that it is one-dimensional, which means that it's just going to be a vector, like it's not going to be two-dimensional, because if this is two-dimensional, then it is a matrix, which means two-dimensional array, right? And this can be like, let's do this way. Maybe this will be much better. Like I can just define an matrix in this way, and I can just type in like this, right? So this is a matrix, right? This is two-dimensional array, basically. But why we use tensors? Like why tensors, right? Why? Like there are already arrays that we can use. Usually in deep learning, we are working with dimensions more than 3. When you think about it, in real life, we are experiencing a 3D dimensions all the time. we cannot physically comprehend a 4-dimensional or 5-dimensional object because we never experience it, or maybe we are not capable of like understanding it or realizing it or kind of defining it almost. So in deep learning, this is a quite common occurrence. Usually in deep learning, you will work with multiple dimensions, maybe sometimes more than 5, hundreds or thousands of dimensions sometimes. And this will get quite complex, and you cannot really call that an array. At that point, we define a data type called tensors, and this basically generalizes the definition of arrays and just calls it n-dimensional arrays. So simply, tensors are just n-dimensional arrays. What do I mean by this? When an array you have passes more than, like, if it has more than 3 or 2 dimensions, you can call it n-dimensional tensor. And also, still, if a dimension is 0 for a tensor, this is a scalar value, just a single number. If it's 1, it is basically a vector, right? So it's an array. So with the definition of tensors, you can also expand the definition into already existing definitions like arrays or matrices. So you can say that 2 dimensions are just matrices, matrix, so on and so on. So why we use tensors to define or kind of represent data more than 2 dimensions. But what are the other advantages over arrays? There are 2 main advantages. The first one is, let's just type in like this. The first one is that how can I say this? The first advantage is that tensors, how can I don't want to write everything down, that's why I'm thinking a bit. So how can I explain this in a much better way? Let me think a little bit. Okay, so previously we defined a device, right, in our workflow, and it's bound to our GPU. Usually when in Python, when you are working with regular arrays, especially using NumPy, it's not possible to use your GPU as a device or as a processing unit for your array. So if you want to do a computation with several arrays, you have to use this CPU, because it's not possible to relocate that data into your GPU. So this means that you cannot get use of parallelism in your workflow. But in tensors, you can use parallelism to your advantage with the GPU, okay? Which means faster. This means faster computations with using parallelism, because you can distribute your work, distribute the computation into several cores, and this will give you huge advantage and much better efficiency. Let's just make this into like a list so it will look nicer. This will enable you to do parallelism and also efficiency, more efficient. Let's just type in faster and efficient. And in maybe this is not that much when you think in lower dimensions, but if you have a huge data that you need to process over and over again, this saves a lot of time, a lot of resources, and also a lot of money. Another advantage that we have, you don't know about this right now, but training or deep learning is an iterative process, and it uses derivatives. There's a algorithm, or there is like a operation called backpropagation that is the center of training our model. If there is no backpropagation, you will not be able to train your model. And because of backpropagation's nature, we need to be able to calculate the derivative of any data we have. And tensors make this available. How can we say this? And we can call this like a ability to calculate derivatives. Okay, this is important. We want to do this because of backpropagation, and this enables training. And this is pretty important, because if there is no training, then there is no artificial intelligence, because this is the key point of iteratively improving your model. These are the two main advantages of tensors over arrays. That's why tensors are used. So how can we define or create a tensor? Let's just create a simple tensor named capital T, and I can use a function from Torch, and I can just create a tensor, and I can also specify some attributes like data type, and I can just specify that it's going to be a floating point, and I can also specify a device for my tensor, which is the device that I'm going to store my tensor and do my operations with. Let's just print this out, and as you can see, this is just a tensor with just one element and on my CUDA device. So, but this is just a single number, so this is just a zero-dimensional tensor. What I can do here is I can add more elements and pass it as like a list of elements, and it will automatically convert this into a tensor. Now this is an array or vector or one-dimensional tensor. If I want to add more dimensions, I can easily add this manually by just inserting another list of elements, and I can do that with just typing everything out. And now this is a matrix, or also called two-dimensional tensor. Okay, I can do the same with other I can just increase the size as how I want, but I'm just going to stop it here. So this is the basic way of creating a tensor. There are other ways to create a tensor without writing every element manually. These are created for your convenience. One of them is pretty important, and I'm going to talk about the reason first. In deep learning, you want to be able to create tensors for certain operations. For example, in a lot of cases, you want to be able to create a tensor that all the elements are 0. I can do that with using a function called zeros, and I can specify a size and also other attributes. Let's just say like 1, and I can just type in data type as well, and I'm going to take this from here to not do the same thing again, and I can just print this out. Now I have a tensor that consists of zeros at the size of 1. If I increase to 10, I will get like a tensor of 10, like a tensor, one-dimensional tensor of zeros, which has 10 elements. If I wanna turn this into like a two-dimensional tensor, I can just easily do that with providing two-dimensional size values, and I can just do that, and I can just create this using and giving different size values, and I can do this with like crazy numbers as well, maybe like more than 2 dimensions, like 4 or 5, maybe like doing this. I can just create a tensor on like different sizes and shapes that you cannot really comprehend in real life. but let's just leave it at this for now. You can do the same thing with ones, like you can create a tensor consisting of ones with the same approach as well. So that's one of the useful ways to create a tensor. I can also use like some of the, you know, like other ways, like maybe linspace. This helps you create a tensor that starts from a number and ends in a number as well, and goes with a steps. And I can again define. I think I need to specify this as steps. What is happening here? What's wrong? What's wrong? Closest. Oh, okay. There is something wrong that we're doing here. Do I need to specify this as 5? I don't remember. Maybe 2. Let's check it out. Let's learn it together. So I can do this and just print this out. Okay, so this makes sure how many elements there are. Okay, so when I type in 5, there are like 5 elements, and it just separates. It's just like divides everything to get that much of elements, and like how can I say this in a much better way? So it makes I'm kind of having a hard time right now with myself. I can just type in any element, any number of elements, and it will just adjust the step size based on the number of elements I want. So if I just create this, and if I check how many elements there are, I will get the number that I put it as an attribute, as an like a variable here. I can also type in like 1,000, and this will be 1,000, and I can also type in 1, and I will get 1. Like that's just another way of creating another. And there's another way that is similar to this called arrange, and I can just again specify where to start, where to end, and step size also. And I can again define the data type and device, and I can just print this out. Now this starts from 0 and ends at 50 or 49 to be exact, because this is excluded, and it will go with the steps of 1. If I change this into 2, then I will just get the result based on this steps value. Yeah, that's it. Let's just leave it this at 1. Yeah, so these are the other ways to create different ways of like different types of tensors. So when I create a tensor, or when I have a tensor at hand, usually I don't know, like this line, the tensor comes at me and I don't really know much about it. So what I need to do is to analyze the tensor to have an understanding of its shape, its characteristics. There are some methods that we can use to get an idea of a tensor, which shape it is, how many elements it has. Let's say that I created a tensor like this here, I can reach and get its shape value, which is just a single number in this case because it's a vector. And I can also get its number of dimensions, which is 1 because it's a vector. And I can do other sorts of things. I can just get how many number of elements there are. There's 50 elements here. I can maybe calculate the maximum and the minimum value of it. These are quite obvious, but I can still do that. I can just get the maximum and the minimum value of them. I can also calculate the sum of values as well. Okay, I typed it something wrong. And I can get the sum of the values inside. And also I can calculate statistics of it. Like I can calculate the mean value. I can also find out about its median. Like this is just a basic operation. And I can also calculate its variance, or maybe like STD, standard deviation, and also maybe there's I think what was it? I forget. Yeah, I can also reach to its attributes, like what's in what device it is stored, and maybe like its data type, you know, these. So this is quite important when working with tensors. You can like get a lot of information with using these. So let's just print out its shape and also its number of dimensions, because this is going to be important later. Okay, so what do we talk about next? Okay, so generating tensors, right? There is one more thing that I want to talk about, which is using randomness. Okay, randomness is important because, you know, let's just go over this in a much better way so you can understand what I'm talking about. Okay, I wrote down something that doesn't make sense. Okay, in deep learning, you train your models, and this is an iterative process. What you need to do in training is that you need to initialize stuff randomly, initialize weights, specifically weights randomly. I'm not going to talk about this right now, but some, like in certain situations, you need to be able to create tensors randomly based on some distribution. We can do that with some functionalities. There is rand, and there is also rand n that I'm going to talk about today. There are other ways to do this probably, but I'm just going to talk about these two. And these follow different distributions. Okay, let's just make this like a list. So I know that there are like different distributions and also different rules, different rules that it follows to generate it. Let's just generate a random tensor, and let's specify like size of 5 by 5 maybe, and maybe again use not that, like get these. I don't want to type everything by hand again, and let's just print this out. So that is our random tensor. But how is this generated? What are the rules? I can just read it from its documentation. It tells me that it returns a tensor filled with random numbers from a uniform distribution. So this follows a uniform distribution. Let's just type in here so we remember. And this is between 0 and also 1. Isn't that interesting? This is between 0 and 1. Okay, I don't like this. Okay, this is between 0 and 1. And I can also check this with using like max and also min functions. And as you can see, the max is 0.97, and the minimum is 0.06. So these are between 0 and 1. Let's try out the other one that we've talked about. Let's just add in like single n here and just run this. That this is our random function, but as you can see, there are negative values. It's different from this because this was between 0 and 1, so they were all positive. But here are negative values as well. So when I read the documentation of this again returns tensor filled with random numbers, but from a normal distribution. And this will have mean of 0 and the variance of 1. And this is also called the standard normal distribution. So I can come back to here and I can specify this standard normal distribution. So I know this follows uniform distribution and this follows standard normal distribution to generate the random values. And I can also again check these with calling the necessary functions. This should be the variance of this. I don't know if this is true. Let's check it out. So when I run this code, I get mean of minus 0.16 and get the variance of 1.6. So this is not really correct. Like, it told me that it will have mean of 0, but this is not exactly 0, and this is not exactly 1. There's stuff that you need to, research, make your research extra, like just look around and see for yourself. But I'm not gonna go into this right now, but you can just check, the rules. And that's it for the random generation of tensors. This is important, as I said, because we need to usually do this to initialize weights, and like just add an explanation. Initialization. Okay. Yeah. So the randomness is important because we are using this feature in initialization of weights while training our model. That's why I wanted to talk about it. And yeah, that's it for today. I think this is enough. I'm going to keep it short. I'm going to talk more about tensors on the next video. Thank you for listening. Thank you for watching. I hope you learned something new from this. I hope to see you soon, and take care.